Okay, 2 point charges Q1 -2 nanocoulomb and Q2 positive 3.2 nanocoulomb are placed 3 cm apart as shown in the figure 7. Determine the magnitude and direction of the resultant electric field intensity, okay, at point M. Alright, so these questions want us to find the resultant electric field intensity. What is electric field intensity? That's right, that's electric field strength or electric field density. You also call electric field intensity. So this is to find the E. Okay, since you say resultant, so you want to find the total or net. This is the net electric field strength, or can say total electric field strength. All right. So at point M, specifically point M. So position at point M. So which is at here, at this point. Okay, not other point, only at this point. So we need to give the magnitude and also the direction. So you not just calculate, you also need to find out the direction, yeah, in the angle form. Okay, so seems we have 2 point charge here, Q1 and Q2. So there will be 2 electric field at point M, but these 2 electric field will combine to form the resultant electric field strength. Okay, so okay, first of all, we need to draw out. We need to draw out the direction of electric field due to charge 1 and the electric field due to charge 2. So we have learned about electric field strength direction. Okay, for positive charge, electric field is going away from positive charge. But for negative charge, the electric field is going towards the negative charge. Okay, so let's draw first. First of all, for let's say Q1 is the negative charge. So the electric field should go towards. Okay, should go towards. Okay, so at point M, the electric field should go towards the Q1. So go towards the Q1. So we can put this as E1. Okay. Whereas for Q2 is positive charge. Positive charge, electric field is going away. From the positive charge. So positive charge, electric field is going away. Okay. So at point M, the electric field should go away from the positive charge. Like that. So this is E2. We label as electric field due to charge 2. Electric field going away from the positive charge. So we already got the both electric field, okay, caused by this 2 point charge. Now we need to calculate what is the value of E1 and what is the value for E2. Okay, so using the formula electric field strength KQOR square. Okay, so first we calculate E1 due to charge 1. Remember, electric field just depend on one charge, only depend on point charge, the one who give out the electric field. Okay, not like electric force. Electric force need to depend on 2 charge, the point charge and test charge. Right here we don't have test charge, we only have point charge. Okay, one charge only who give up the electric field. So this is KQ1 over R1 square. Okay, and so let's calculate. So K is the constant value for Coulomb's law. Okay, we can find in the list of constant. We can not the Boltzmann constant. Remember, not the Boltzmann constant. It is here constant for Coulomb's law, which is 9 exponent 9. That's the value. Yeah, 9 exponent 9. Okay, what's the charge? See, remember, be careful. Here we have nanocoulomb, centimeter. All this you have to change to SI unit. All these have to change to SI unit. So and also for electric field, it is I did say before, for vector quantity, when we want to find the magnitude of vector quantity, the sign on charge we ignore. But for scalar quantity, to find the magnitude, the sign of charge, you must have the positive and negative sign. But for vector quantity like force and electric field, to find magnitude, we ignore the sign on charge. So if the charge has negative sign, we ignore. Okay, so this is to find the modulus of it. Modulus, this is a vector quantity. So we know that the charge Q1 is a negative charge, but we ignore. Okay, ignore the negative sign on Q1. Yeah, ignore the negative sign. Yeah, magnitude, we just want the value. We don't want the negative sign. Okay, so so we just put 2 nanocoulomb. Nano is we need to change to SI unit. Nano is -9. -9. Okay, divided by R. R, how far is it? Yeah, this is a right angle triangle. So by using Pythagoras theorem, this is 3 cm, this is 4 cm. So this one should be 5 cm, right? 5 cm. So change to meter. 5 cm is 5 exponent -2 meter. Because centi is exponent -2. Remember, you must have square. We have square the distance. Many students forget about the square. Okay, so let's calculate first the value. Let's calculate the value. 9 exponent 9 multiply by 2 exponent -9 divided by 5 exponent -2 square. Okay, so what's the value? Yeah, I got 7,200. The unit is Newton per coulomb. Okay, because if you look at the force per unit charge, electric field is force per unit charge, so it's Newton per coulomb. Yeah, Newton per coulomb. That's a unit for electric field strength, Newton per coulomb. So we got already the E1. Now we need to calculate E2. Okay, calculate the E2. So E2 also use the formula KQR square, but now it's charge 2, distance R2 square. Okay, remember this one is just to find the modulus, the magnitude. Okay, charge 2 is a positive charge, so okay, never mind, it's positive. Now let's calculate. K is 9 exponent 9. Calculate the value. Q2 is 3.2 exponent -9 coulomb. Okay, and then divided by how far is it from point M? 4 centimeter. So 4 centimeter, you change to meter. Centi is -2. Okay, centi is -2, and then you have square. Don't forget the square. So again, we calculate 9 exponent 9 multiplied by 3.2 exponent -9 divided by 4 exponent -2 square. Okay, so I got 18,000. I got 18,000 Newton per coulomb. Okay, so I got the value for both E1 and E2. E1 and E2. Now we need to find the resultant. We can find the resultant already. Okay, once we have these two values, how to find resultant? We need to resolve into x and y components. So let me draw out the table first. Okay, now I have the table ready. So I need to write down, okay, this one I need to resolve the x component and y component. I need to resolve this E1 and E2. Okay, and then the last one is the resultant electric field for both components, x and y components. Okay, so first of all, I need to find out at the angle, I need the angle. Okay, look at E1. Okay, I need to draw, you know, the axis, you know, x-axis. Oh, sorry. X-axis, this is the x-axis, and also this is the y-axis. Okay, so to resolve the E, I need the angles. I need angles, so I must know what is this angle, isn't it? I need to know what is this angle, theta. Okay, so to get that angle, I can I have this 3 centimeter and 4 centimeter, so I can use you know, trigonometry. And I also know this is the 5 centimeter, right? This 5 centimeter. So okay, I can write something like okay. So okay, first of all, E1. Okay, one more thing you must remember when you convert it to x and y components. Okay, vector have direction, isn't it? We use positive negative sign to represent the directions. Okay, where is it? This one. I want you to remember this. Okay, I want you to remember this. Okay, I put it over here. So remember, whenever we talk about electric field strength or electric force, okay, both of these are vectors. Vectors have direction, and we always use positive and negative sign to represent their directions. So direction going to the right, we always say as positive. Direction going to the left as negative. Direction going upward, positive. Direction going downward is negative. So even though we don't include the negative sign in the charge when we calculate the value, the magnitude, we don't include the negative sign. But when we talk about direction, we need to include the negative sign if we are talking about direction going to the left or direction going downward. That one you must have positive and negative sign to represent their directions. Okay. So now talking about E1, E1 is going to the left and going upward. So for x component, it is negative because it's going to the left. You see that? Because it's going to the left and going upward. Do you see that? So E1 is for x component is negative because going to the left, and okay, maybe I write a little bit upwards here, negative. Okay, and then we have you know, this one is E1. Okay, how to find the x component? Adjacent to the angle. Okay, for x component is adjacent to angle theta, so we just put as cosine theta, right? And then for y component, it is going upward. So going upward is positive. Going upward is positive. Just put as positive E1. And then this one is opposite to the angle. Opposite to the angle, or say no angle. No angle, use sine theta. Sine theta. Okay, no angle, use sine theta, or opposite to the angle is sine theta. Okay, so we need to know what is cosine theta and sine theta, right? So we can use trigonometry to find out. Trigonometry. So for that theta, we can use we have these 3 cm, 4 cm, and 5 cm. So first of all, let's start with cosine theta. So cosine theta should be 4 cm over 5 centimeter. So the centimeter no need to care about. So we already have this. Cosine theta is 4 over 5. You see that? So do you need to find angle theta? No need. Because why? We no need to find angle theta. We just find the cosine theta, because we can straight away substitute this 4 over 5 into here, into cosine theta. So what is needed here is the cosine theta, not the theta. Understand? We can straight away substitute this 4 over 5 into here. Save your work. Understand? Save your work. Also, we can straight away find the sine theta over here. Sine theta here is sine theta. Sine theta is opposite over hypotenuse. Okay, opposite over hypotenuse, which is 3 over 5. So you can also straight away substitute this 3 over 5 into the sine theta here. Understand? That's the trick of, so you no need to find the theta, save your time, save your work, save your effort. Okay. All right. And then okay, now I can find already. All right. So equal to negative. Okay, I can write as negative. Okay, what is E1? E1 is 7200 and multiply by cosine theta is 4 over 5, which is equal to, and then wait, okay, let's calculate first. Negative 7200 multiply 4 over 5. Okay, so what do you get? I got negative 5760. Okay, and then okay, I got the x component. Now how about the y component? Y component is 7200. Oh, sorry, 7200 multiplied by sine theta. Sine theta is 3 over 5. 3 over 5. Okay. 7200 multiply 3 over 5. So it is 4320. Okay. That's the y components. Okay, very easy. All right. So now I need to find the E2. E2 is just x component. It's just x component, so the y component is 0. The y component is 0. The x component is only x component and is going to the right. Vector going to the right is positive E. So this one is positive. Positive E2. Positive E2 is totally x component. E2 is 18,000, so it's positive 18,000 to the right in x component. So I got all resolved already, my vectors. So now is to find the resultant EX and resultant EY. Okay, let's calculate. So negative 5760 plus 18,000. So it is positive going to the right. That means I got the resultant in x component is going to the right. Okay, and then for the y component is also positive 4320. So I can see that the resultant EX is going to the right because it's positive value. I see the sign here, positive. That means it's going to the right and going upward. Okay. So I can write like this, going right, going upward. Okay, so I can redraw my my resultant. So my resultant. So resultant EX and resultant EY, both of them are positive going to the right and positive going upward. Okay, so my resultant E, this one should be my resultant E. So what? And then I need to find angle theta. Yeah. In reference to positive x-axis. Okay, first of all, I need to find the magnitude of my resultant electric field strength, which is just more, find the square root, Pythagoras theorem. Total EX square, the same thing you learn from your first semester. Okay, and then okay, square and square root. Okay, so 12240 square plus the 4320 square, and then we square root the whole thing. So I got 12,000. Okay, I better make it in standard form. 1.298 exponent 4 Newton per coulomb. Okay, that's my magnitude of my resultant at you know, point M. That's my resultant electric field strength at point M. And then the direction, I need to give direction also. Okay, not just the magnitude, I need the direction also. Modulus, you know, modulus total EY over EX. Okay, so so what's, I need to anti-tangent, don't forget. I need to anti-tangent. So okay, so in the end, what do I get? Let me calculate. 4320 divide by 12240, and then anti-tangent, sir, and it is 19.44 degree above the positive x-axis. That's the answer. Okay, okay, it is, yeah, above the positive x-axis. So am I right? Yeah, 1.30 exponent 4, almost there. Newton per coulomb, unit must be correct. 19.4 degree, 19.4 degree, that's right, above the positive x, above the positive x-axis. That's correct, yeah? My answer is correct. So that's correct. So the resultant electric field is actually over here. As you can see, it's like almost like over here. That's the resultant EM. Okay, that's my resultant EM. So okay, okay, I hope you understand the working. See you in my next video.